Welcome to EDU World Space.
Okay, for this problem, you have one charge on a insulating support. That just plays the role of holding it still, and making sure that it doesn't move. And so there's your Q1, and then you have Q2 being launched at it, and you want to know a few things about the trajectory. The first thing is, it was given that you know its speed here. What is it? And then let's say that this distance is 0.8. What is the speed here? And this distance is 0.4. Ooh. So that's part A, 0.4 meters, 8.8 meters. And then the second part asks about how close does it get. So you want to do energy conservation here. So you can say E initial is E final. The initial kind of energy there is it has kinetic energy plus potential energy due to the Coulomb interaction, and then you have kinetic energy final plus U final. And so when I say initial would apply at any point, and final would of course apply at any point, but we want to use something where we particularly know the value of these two things. So that's when they tell us that it's going however fast it's going when it's at 0.5 meters. So it's 1/2 mv squared. And then this U initial is this K Q1 Q2 over R. And then that's equal to 1/2 mv final squared plus K Q1, oops, well, that's a 1, over R, and then let's use R final and then R initial. And then I'll say V initial is, what do they say it is? Let me check. V initial is 22 meters per second. And then our initial is 0.8. And then mass initial is, it's 15 grams, so that's 0.0015 kilograms, because there's 1,000 grams per kilogram, so 1, 2, 3. And then K is your constant, the 9 10 to the 9. And then what else? And then your Q's are given. So 2.8 times 10 to the minus 6 and 7.8 times 10 to the minus 6. And so if you plug all of that in and solve for VF, oh yeah, and then your R final is 0.84 meters. If you plug all of that in and do the algebra, which I'm not going to do, but just because these videos are meant to be a bit shorter, but you can definitely like Google and hopefully look in the book for some examples of algebra. But you basically just plug in all these numbers to a calculator and then bring this to the other side, multiply by 2, divide by m, take a square root to get the velocity. And so when I did that, I got that the velocity was 12.5 meters per second. So I think it makes sense that it's smaller because it's kind of like they're repulsing each other. So like the Q2 is going towards Q1, and then it like gets slowed down. And so let me do part B. So it wants to know how far it goes. And again, you want to use energy initials, energy final, and you want to use the same exact equation, but you want to use the same equation except V final goes to 0, right? Because like if it's can't go any further, it's stopped for a moment at least. And you want to say R final equals question mark. So you want to solve for that. And if you do that, perhaps you will get what I got. And I to solve this, I actually just stuck it in Mathematica. Although if you're in this kind of class, it's probably a good exercise to do it by hand. 0.32 meters. So it makes sense. It's less than 4.4, which we'd expect.